Hello everyone! Most of us, when we start our development career, we adopt a development methodology. Typically, the most common one is BDD. That stands for Bug-Driven Development. So in bug-driven development, you create a bug and then you move on to fix the bug and then you create the next bug and so on and so forth. But there are some other development methodologies: behavior-driven development, test-driven development, extreme programming, and so on. In this video, we are going to explore what does it look like to apply test-driven development principles in OutSystems development. So let's check this out. My name is Barbosa and I'm a developer advocate at OutSystems. Let's start with some context about the application that we are going to develop. The product owner gave us a challenge to say, okay, we need to create a loan application, something that the user can input his loan parameters when borrowing some money, and it can figure out what the monthly payments are, what type of loan we have, the interest rate, and so on and so forth. In test-driven development, requirements are often translated or presented to us in the form of scenarios that describe the behavior of the system. The first scenario that we have is calculate payment. We have the description here, given a principal amount, when the interest rate is fixed and the loan term is fixed, then the monthly payment can be calculated. This describes the intended behavior of the system. Included with the scenario, we also have been given the scientific formula, so to speak, on how to calculate the payment, and also a nice spreadsheet that can generate examples for us. So it's going to be really easy to test and understand what the system is supposed to be doing. The essence of test-driven development is a series of steps that impose a certain discipline to your coding. The first is write a failing test. At this stage, your only concern is how are you going to present your methods, your classes, whatever you're doing to the world. And it's a very good way to think, how are we going to test this? Because if we are thinking about how do we test a certain method, then we are making that method ready to be used by the external world. The second step is you make the test pass. This is where you actually do the code. So you already established how does your method communicate with the world. Now you're going to code it. You're going to solve the problem. There are different approaches here. You can solve the problem as fast as possible and just commit any coding scenes that you want. Don't worry about optimization. Don't worry about patterns. Don't worry about anything. Just find a solution for the current problem. And finally, the third step is the refactor/optimize step. This is where you make your code elegant. This is where you optimize your solution. This is where you apply development patterns, you eliminate duplication, and so on. So this is where you make yourself proud of the code that you are writing. So let's talk a little bit about the setup that I have here. I've got two applications, the loan app and the loan app tests. On the loan app, I'm going to have a financial utilities service. This is where I will do my payment calculation, and still empty, but we will have the actual loan app in this module over here. If we go to the loan app tests, you can see that I am referencing the TDD framework. This is where the tests will be executed. So it will consume from the financial utilities service and it will consume from the TDD framework. Now, about this TDD framework, you can use this one, or even better, you should actually be using the official one, which is called BDD framework. If we go here into the Forge and search for BDD, you will have the supported and official BDD frameworks over here. My personal choice, I use this one. I like it a little better, but the official one, it's the one that you should be using. Let's go and open these applications up. So I'm going to load here the app tests. As you can see, it's fairly empty. It already has a little bit of structure, but it's fairly empty. And let's go here and open the financial utilities service so that we can start this example. A quick refresher for the scenario. We need to calculate the payment, and the payment needs the number of years or the number of payments, the interest rate, and the principal, and it will output the monthly payment amount. For this scenario, we are on the step of writing a failing test. In order to write a failing test, I need to have the public method that the test is going to reference. So we'll start there. The financial utils service created a payment calculate method, which is a public method over here, and it has these input and output parameters: principal, interest rate, number of payments, and payment amount. Now remember, at this stage, I'm not going to implement anything, so I just leave it like this. On the testing side, I'm using TDD. Be sure to use one of those. BDD is a recommended one. And I've got the scenario over here. This scenario, it has a bunch of steps. Actually, this one only has one. And this step is going to execute this step A0 calculate payment, right? So let's take a look at it. And as you can see, the step 0, it's going to call my method that it's coming from the financial services. It's going to pass some parameters there. So principal, interest rate, and number of payments, and it's going to output something. After this is executed, I am going to call the assert value and check to see if the payment that I get from the method is what I'm expecting over here. Let's test this and see what's going on. And as you can see, the test fails miserably. Of course, there's no implementation there, so there's nothing else to do here. We are done with the first step, write a failing test, and now we are going to move to the second step. So the second step is make the test pass. So you are on the green step of the test event development. In this step, this is where you actually find a solution. This is where you code. Our example is very simple, so we just need to go here, and I'm gonna use another development technique, which is TDD, also known as copy and paste driven development. And I've got what is a simple mathematical formula, which applies the formula that you've seen before. All right, let's test this and see this in action. So I publish this one, and then once this is done, I publish this one, and I am now ready to re-execute the test, and the test is passing. So as you can see here, the expected values are the same as the obtained values. So it's all good. Now the third step, the blue step, refactor optimize, I'm just going to skip it because honestly, folks, there's not much you can do in optimizing a mathematical formula. But just because we have one passing test for one scenario, it doesn't mean that we don't create more tests for the scenario. In this case, what would happen if I created a negative interest rate or a negative borrowing amount or even some negative years? So we need to often create additional tests to make our methods more consistent. I should be creating one test and then coding the test and then creating the test and coding the test, but because there will be no changes to the behavior, I am going to go a little bit against the test-driven development principles and just code the 3 tests at the same time and then resolve it at once. Back to our testing application, we now created 3 more tests. We now want to see an error when the principal is less or equal to 0, or when the interest rate is less or equal to 0, or when the number of payments is less or equal to 0. So let's take a look at those methods. We have the start, we have the payment calculate, where the principal is 0, and then we immediately have an assert fail. This means that I'm expecting the flow of the code to go somewhere else. In this case, I'm expecting to generate an exception. So this assert fail, if the code reaches here, it will just say the test didn't pass. On the other hand, on the all exceptions, I'm asserting for a message of the exception. This assert value is looking for a certain message that it's coming from the exception. The other ones are very similar, with the exception that this one is checking if the interest rate is 0 or less, and this one is checking to see if the number of payments is 0. Let's check how this is working. So we go over here, and as you can see, the tests did not pass. I didn't change the code at this point, the test didn't pass, and we are now ready to go into the green step and execute this code. Let's take a look, and with a little bit of copy and paste, this is what the code looks like now. My payment calculate method now includes some checks on the server side, actually, and if the principal is 0 or less than 0, it will give me the proper exception. So the messages that I put here are the same messages that I'm evaluating on the other side. Let's take a look now to see how this works. So let me publish this really quickly over here and publish over here. And once it's done, let's go and refresh our method. And there you go. The tests are now passing. The expected value of the test and the 3 tests that are going to verify if the input parameters actually meet the requirements of the behavior. Scenario number 2 introduces a new behavior, which is once I calculate the payment, I want to know the payment schedule. So I want to know every single detail of every single payment. How much am I still owning? How much did I pay in interest? How much did I pay in capital? What is my final balance? And so on and so forth. So given a principal amount, when the interest rate is fixed and the long term is fixed, the monthly payment schedule over the long term can be generated. Again, we are describing how the system should behave. And again, we are going to start by creating a failing test. Again, I created a payment schedule method, which is public, and put the public interfaces to it. So it accepts a principal, an interest rate, the number of payments, and it's going to output a payment schedule list, which has the same information that we saw on the requirements example. On the other side, I am going now to create the tests. And we have here the new scenario. So let's take a look. In this scenario, it's going to call the payment schedule, which is this principal, interest rate, and number of payments, and then is going to assert and try to understand if the principal on payment number 10 is 79,580. So this comes from that spreadsheet of examples, and we verified that the expected principal at payment number 10 would be this one. Let's check it out and see what we can see. Back to our loan app, and we can see that the test absolutely fails. Now, it didn't fail exactly the same way that it failed before with the red condition. It's failing because it's getting an exception. I am trying to read item number 9 of an empty list so that it's going obviously to throw out an exception. However, it is not the exception that I'm expecting. Let's now go into the green step and fix our code. So we go over here to our financial utilities, and I'm going to copy and paste the code for this method. And there we go. Here's the code. It's essentially doing the same thing. It calculates the payment, and then it iterates through every single payment and calculates those little details on the payment terms. The balance, the interest rate, and so on and so forth. Let's go back and take a look and see how this is going. And now, as you can see, the amount of the principal for payment number 10 is in fact the same as we are expecting, and also the last balance is 0. So we actually included 2 different tests in this step. Considering an eventual blue step in terms of optimization, at this point there is not much to optimize here. Yes, I do understand that it has the same parameters and it's executing the payment calculation method, but all in all, they are doing slightly different things. One only outputs the payment and the other outputs the entire details of the schedule. Moving on to scenario number 3, the extra payments. Given a fixed principal amount and interest rate, when an extra payment is made, the monthly payment schedule over the long term can be revised. This will imply that we're going to take something from the payment calculation and we're going to take something from the payment schedule and recalculate things based on a change on a certain payment number. So again, red step, let's get started. We've got this payment extra method over here. It does require in which payment number do I want to execute the extra payment. We've got the extra amount. We do have the list coming from the payment schedule, and we have the interest rate because we need to recalculate everything again. And then we have the list out with the updated payment schedule. I have a lot of doubts about this. Although we are only supposed to move fast into the solution on the green stage, I'm actually not giving enough thought about how would the payment extra interface be like. And I'm doing this because I want to actually have some opportunity to refactor this later. On the testing side, we have an extra test over here, which is the calculate payment with extra payment, which uses this method. And we have a payment schedule. I need a payment schedule to start with. Then I take the output of the payment schedule and I'm using the payment extra to say at payment number 10, I want to pay an additional $20,000. And also I'm asserting for the balance in different steps: before the payment is executed, when the payment is executed, and then after the payment is executed. So a good segue to understand if the impact of this payment is the expected one. Let's take a look at how this is going, and we have an exception as expected. We have a failing test. The monthly payment, it's not outputting whatever I need to output. Let's move on to the code implementation, to the green step, and implement our method here at the extra payment. Let me copy and paste the code. And here we go. Essentially, we have a cycle that goes through the payment schedule. It tries to figure out if that payment number does have an extra payment or not. And if it does have the extra payment, it sets the correct balance and keeps recalculating it until the end of the payment term. Let's take a look on the other side. How does our test look like? And now we can go back to our test application, run the tests, and verify if the test is now passing or not. And as you can see, it is. With the new extra payment in moment number 10, it's figuring out, okay, what was my balance at 9? It checks out. What is my balance at 10? It did check out also. And what's my balance payment number 11? However, I am really not happy with this. If we take a look at the payment extra and compare it with the payment schedule, we see that in terms of algorithm, this is doing more or less the same thing. So I realized that I may have made a mistake. I would actually prefer to extend the functionality of the payment schedule and have the extra payment possibility here on this method. So the payment schedule in essence is outputting me a schedule, and it can support changes into that schedule. So more or less is under the same thing. But now I realized the mistake. This will force me to change the interface of payment schedule. So although test-driven development on the blue step, when it says refactor, you shouldn't be changing the signatures or the public interfaces to your methods, I'm going to need to do that. I'm not expecting a change in behavior for the payment schedule, so I will code this in a way that I'm not going to break something. But this reveals the importance of the red step. When you are designing your APIs, you need to really be careful and think about things. And I just kind of skimmed through that step. If this was something that was already on production and not something absolutely new that I'm doing right now, this might have some serious consequences. Changing the interfaces is always dangerous, and it is beyond the refactoring process. Refactoring always implies that you are not changing the behavior. With a little bit of dodgy things here under the test-driven development rules or proclivities, I am going to use the optimize refactor step in order to change this. Just copy and paste the code, so let's take a look. The payment schedule over here now has an extra parameter, which is extra payments, and it's set to mandatory no. This is not to break anything that it's already using the payment schedule. In terms of logic, it's pretty much the same thing. Before we were recalculating everything, so let's assume that this just recalculates the entire loan. So we've got the balance local, this will capture the initial loan amount, and then it goes on and on and on, all the payment numbers in order to figure out all the payment details. At some point, it actually checks to see, do I have an entry for an extra payment? And if we have an entry for an extra payment, then it will process it accordingly and just keep going. A much cleaner solution than we had before and much more straightforward to use by the development team. On the other side, on our test application, so we removed the extra payment that we had here, and this payment schedule, I haven't even touched it yet. And as you can see, I don't have any extra payments set up here. Let's take a look. I want to override with my version. Yes, yes, yes. All right, let's open our test page. There we go. And we have a failing test. And there we go. The balance at number 9, it did pass, and it's expected to pass because I haven't done the payment yet. But for balance number 10 and balance number 11, it was supposed to pass. But I haven't put the information in. All the other tests, however, are still passing. So even this one that was figuring out for principle number 10, it's working fine. So let's go over here and add the extra payment. So at payment number 10, I want to pay an extra $20,000 for it. Let's give it a quick publish. And now we have all 6 passing tests. So now the balance of 10 and the balance of 11 are the expected balances. But we haven't seen the demo app yet, so let's take a look at the demo application. The loan app is pretty straightforward. We have here the main screen. It has 2 sections. One that will execute or apply the simple loan calculation, and the payment schedule, which gives us a detail of every single payment number. Let's take a look. Let's see this in action. So we've got here $125,000, 2 years, 5% interest, monthly payment, and the schedule. Let's change this a little bit. So let's say 200,000. Let's say I'm going to pay this for 10 years at 5% interest rate, calculate, and there you go, your monthly payment with all the details over here. First year, second year, third, and so on and so forth. Now, if I want to go here and let's say at month 5, I need to do an extra payment. Let's say I'm going to add an extra $5,000 in my payment. As you can see, the payment is constant through all the months or the payment numbers. And once I added an extra payment, the payment changes, and I can do this whenever I want. Let's say here, I'm going to add another 15,000. And even if I go back and say, hey, I want to add 2,000, it just keeps recalculating the payment schedule. So in terms of conclusions about this exercise, well, one is TDD is absolutely awesome. It doesn't feel that it is about tests. So I didn't feel while I was coding that I was doing 2 different things, coding in one part and testing on the other. It felt like an entire cohesive, consistent process. It does feel that the tests are a valuable byproduct, something that we get for free during this process, and it really saves a lot of time in terms of manual testing. So if you compare test-driven development with bug-driven development, you would typically execute those tests manually over and over again with some kind of interface in order to find out if your methods are actually working or not. This seems much straightforward, and it does seem that it's contributing to the development part, not just doing the tests for the sake of tests or for the sake of a requirement or for the sake of an acceptance test and so on and so forth. This red, green, and blue steps approach, it's also very interesting. It does impose a certain discipline, but it triggers you to think about where are you doing things? How are you going to approach a problem? And how are you going to refactor it? So we have to think about where design is happening in one of these steps. During the red step, there's a lot of things happening, a lot of decisions that you already have to make. It's not just about writing the code. You need to understand what will be the public interfaces of your methods. You need to understand where your methods are going to sit. So there's a lot of architecture and decisions that need to happen at this stage. The green part, you're just solving the problem. Now you don't have any more concerns with the world. It's just yourself and the code, yourself and the machine, yourself and the problem. It's that challenge of solving the problem that's really interesting. And after the blue step, where you just make it look nice. You just make it more efficient, optimize it, make it elegant, apply your best practices and so on and so forth. If you want to play with this example, you will find it on the Forge, so you can download it from there. There's also a couple of blog posts about TDD and OutSystems, one of them directly related with this video, and also suggest that you take a look at a few videos. All of these links below on the description so that you can enjoy test-driven development a little bit more. Thank you everyone, I hope you have enjoyed this video. If you did, give us a like. If you didn't, don't bother to give us a thumb down. Do, however, subscribe and turn on notifications for this channel in order to keep you updated of the new videos under this channel. So cheers everyone, and don't forget, go build those apps using test-driven development.